Well, hello, everybody. Good morning, good afternoon, good evening, good night, wherever you may be, somewhere across our lovely world. Thanks so much for joining us here on the live for the one and only Serverless Office Hours. We are streaming on different channels, but even more channels. So if you've joined us on the AWS Twitch channel, you're more than welcome. If you've joined us on the AWS events page from YouTube, that's great. Also via Facebook and also via LinkedIn Live. This week is super awesome because it's not just myself and Eric who's super awesome, but we've got three absolute gurus who are going to be talking about some cool sort of Kafka stuff. So I'll actually introduce Anton first, because Anton's been on the show beforehand, but the two other experts are, they're next kind of level. So Anton, you've been on Serverless Office Hours before. Tell us what you do at AWS and how come you fell in love with the world of serverless.
Yeah, absolutely. Hey, everyone. Good to see you. I'm Anton. I'm a principal solutions architect here at Serverless, AWS Serverless, and I'm almost close to my fourth year doing this, and I absolutely love it. So I work primarily with large organizations to help them to adopt serverless, be efficient with serverless, and I cover quite a lot of various services like Lambda, Event Bridge, Step Functions, API Gateway, name it. If it's serverless, it's probably me.
Cool. Awesome. I love it. Anton, thank you so much. And next up, Tarun. Well, Tarun is not just anybody, but he's literally a principal product manager within the Lambda team. So part of Tarun actually builds and decides on the whole product roadmap for Lambda. And we've all been trying to look back on his whiteboard to find out what deep, dark secrets are happening with Lambda, what's coming out in reInvent this year. So we'll have to see if there's anybody on the stream who can actually read what's on the board and can tell us what's happening on Lambda. We would love to hear about it, see what you can spot. Yeah, Tarun, welcome to Serverless Office Hours. Can't believe it's the first time you've been on. My bad, but yeah, tell us what you do at AWS and how you've managed to be one of the top gurus in Lambda.
Yeah, thanks, Julian, and thanks for having us here. I'm Tarun. Everyone, I'm on Lambda. I'm a principal product manager. I've been here. I almost completed 4.5 years, and I've been with Lambda all the while. Like Anton said, live and breathe serverless. Typically take care of our event-driven applications, integration experience with multitude of services, say step functions, SQS, Kinesis, Kafka, and so on. Really excited to be able to talk about more of those here.
Cool, excellent. And last but certainly not least, Tejas. So we've spoken about Tarun, who's a product manager. Tejas is actually one of the software development managers. So this is one of the engineers managing people who writing the code, who literally makes Lambda operate. And that is so cool. That's why I love Office Hours. We can get to talk to the product people, the engineering people, and all the experts. So yeah, Tejas, welcome to Office Hours as well. We've met a number of times. It's so cool to have you on the show. Tell us what you do as part of Lambda, the Lambda team.
Yeah, so excited to be here, Julian. So I'm Tejas. I work with the Lambda event source integration team. If you have ever used integrations with Kinesis, SQS, all of that is owned by my team. We are going to talk about Kafka today. Asynchronous integration, which is S3 notification, SNS. We own all of the backend systems that power Lambda with it. And I also own the Lambda console and developer experience side of it, which includes SAM CLI. I hope you read Eric's tweet the other day on SAM and SAM CLI. So that's another exciting thing that developers should be looking up to this year.
Yeah, definitely. So yeah, a developer experience is a big thing that we're working on Lambda. We did a whole bunch of things last year in terms of, a brand new console based on VS Code, local IDE enhancements, some CloudTrail logging and live tailing, and a whole bunch of stuff. And there's more planned for this year. So it's cool to know that Tejas is all on top of those things. Yeah, for SAM as well, lots more investment we're putting into SAM to be able to make building serverless applications even easier. So just before we get on to all the nuts and bolts of Kafka events sourcing today and streaming today, just remember we are live. So please, we'd love to know where you're from, where you're watching from. We already have somebody who's asking us what's up. So thank you for a bot is asking us what's up. So hopefully we've got more than robots watching. But please tell us where you're from. We are here to answer your questions and comments about anything in serverless in general, but probably specifically a bit about Kafka and about Lambda today. So Tarun, over to you. Kafka is obviously huge for data streaming. Do you want to just paint us sort of the bigger picture of what people use Kafka for and why, in your opinion, people should be using Lambda for processing?
Absolutely. So like you said, Kafka is a de facto standard for like a lot of the streaming applications. And so what customers tell us is we have a lot of customers who want to build modern applications, right? And who basically want to leverage event-driven architectures to be able to build these applications. What they tell us is, hey, Kafka, I want to be able to use Kafka to build these real-time event-driven applications with Lambda, right? Think of high throughput applications. Think of real-time anomaly detection. You could have predictive maintenance if you're in airlines industry, right? ML analytics kind of workloads, what have you. And so customers tell us they want to build these high performance applications. At the same time, they want to leverage the simplicity of a serverless compute client, right? Where they don't have to worry about setting up the client, downloading libraries, and so on. They don't want to worry about auto scaling. They want a cost effective approach, right? And that's where customers tell us they love the experience that Lambda offers. It's both in terms of the connector layer, which is event source mappings, and we're going to delve into that today, and the compute layer itself, which is Lambda function compute, that offer all that goodness of auto scaling, simplicity, and so on. So with that context, that's where we see a lot of that customer feedback coming in around what they love about using Lambda with Kafka.
Okay, cool. Yeah, I mean, I think the story together is so great because Kafka is such a well-established product in the industry. It's open source, and not just open source. It's used. We've got managed streaming for Kafka from AWS. There's Confluent is absolutely huge. One of the sort of starters of Kafka. Many people are running it on-prem, running it on EC2 instances. This is massive infrastructure. And one of the exciting things about Kafka is some people think, Kafka is actually really old. It's sort of one of these old kind of things, but it isn't actually that old. I think it's only 2010 or 2011. Is sort of started by LinkedIn. So if you're watching us on LinkedIn Live, maybe there's probably some Kafka doing something under the hood. That would be interesting, rather meta. But the cool thing about Kafka is how it's actually, I love how it's being reinvented all the time. And, companies like, there's a company like Red Panda, and they are sort of completely rejigging how all of the compute works with Kafka. Kafka can be quite heavy on the compute kind of thing. They've made the small binary, you can run it anywhere, and it just does the synchronization. Another company called WarpStream sort of thought, what we can do, instead of worrying about cross data center replication, why don't we just get S3 to do that? S3 does a pretty good job, and so they built stuff on top of that. And then actually, Confluent bought WarpStream. So there's just huge amounts of compute innovation going, storage innovation, and so that's on the Kafka side. And then we're putting a lot of work in, I know, onto the consuming side, because having a serverless approach for consuming Kafka is super useful.
So I think something to add onto that, Julian. I think as we were mentioning, we're working on the consumer side of things. If you're using Lambda and the ESMs, we're going to talk about ESMs and Kafka and Lambda today, you can literally get your production ready workload in the same week that you start developing, in many cases on the same day. And why that is magical is that we can start processing, what I mean by production grade workload is that we can start processing tens, hundreds, thousands, tens of thousands, hundreds of thousands of requests instantaneously. You don't have to perform any scaling exercises. You have worked, Julian, you have seen the upside. Tarun, Anton have seen the upside of the world. I remember while I was working on one of the teams at Amazon, we used to spend more than a month preparing for peak scale on our services. And I remember the following year, when we switched to Lambda, we ended up saving 2 dev engineers worth of effort. And we used those engineers to build new features for our business that became big revenue drivers. So I know we talk about, this is serverless. We are going to spend, on Lambda, or we're going to spend on provision poolers. We'll talk about that today. But what serverless enables you on the consumer side is to focus on differentiated logic. What makes your business special? You don't have to worry about the infrastructure. You don't have to worry about scaling. You don't have to worry about availability. I don't know how many people know, Lambda provides amazing availability guarantees if an AZ goes down. We automatically move your workload to another AZ. There are innovative features if you're using ESMs and Lambda, like tumbling window. There are features of partial batch failures. You get that with a click of button. If you want to use batching, filtering, you just turn it on in the console, or you make an API call, and it starts working for you. So that's the magical experience, right? You're ready to start accepting production grade workload right away.
Yeah, and you're setting that up quite easily with configuration. It's not not writing a whole bunch of code.
Yeah.
So, Anton, over to you. I know, what are the basics? We're talking about event source mappings. What are they? It's I know it's a resource. It connects Lambda and Kafka together. How does that actually work?
So, event source mapping, that's a very interesting component of Lambda, right? The part that I like, it's kind of built in, right? So you don't need to bring anything external. It's part of your workload. And if you're thinking about any message-based or stream-based workload, you got that source of data, which contains your messages, records, items, events, depends what the terminology you're using, right? And you need to get it from there, right? So it's pretty easy when the volume of data is kind of low, right? If you're processing like 2 messages a second, right, or a few messages a minute, no big deal, right? You just have some interval process that pull in the data, right, and you can process it. But imagine processing 5,000 messages a second, right? And that's actually something I'm gonna demo today. Imagine processing 25,000 messages per second, right? Now, processing the data in your business logic code, it's still your responsibility, but how do you get that data? That's the challenge, right? How do you get the data at scale? How do you ensure that when the volume of data is increasing, your consumers are growing as well automatically? And what's critical, when the volume of data decreases, you also want to scale down automatically, so you wouldn't be paying for that. So that's essentially what ESM provides, right? You just say, hey, I want my function to process data from this particular source. Okay, and you point it to SQSQ, Kafka that you can run on premises, MSK, Confluent, whatever you want, right? Or Kinesis. You point it to data source, hence event source, right? And it just starts doing that polling for you. It retrieves the data, it scales up and down automatically. And from your perspective, you need to make sure that your code knows how to process that data. That is it, right? So, yes, you got tools like, you can still manage things like retries, for example, right? What happens if your code is unable to process the data, right? We've probably all heard of poisonous pill message, but the ESM will handle a lot of that for you, like retries if your code fails, etc. So that's the huge benefit of ESM. You're focused on your business logic, and ESM takes care of actually bringing more data for you to process.
Yeah, thanks. And Poonam's, I appreciate you listening very carefully. When can we expect to see the innovative features that you were just mentioned, tumbling windows? So I was like, when we're talking about tumbling windows, we don't quite have that for Kafka yet. And I heard that as well, and I was like, glad to see, Poonam, that you are working. So yeah, I don't think we've got any, unless we have got anything to announce today, I don't think we've got anything to announce today for tumbling windows. But yeah, tumbling windows is, short-term analytics that you can currently do for the Kinesis ESM. Not available for Kafka yet, but seems as though there's a use case for it. So yeah, I know the team are already thinking about these kind of things. But yeah, Poonam, awesome to know that you're listening, and thanks for joining us via YouTube and listening very carefully to what's been going on. So cool. And so, yeah, one other thing I just wanted to highlight as well from the ESM point of view, that Kafka is obviously very big in the Java world. So a lot of it's written in Java. People are used to writing their application code in Java. But if you're consuming code in Java, but if you're not a Java shop, but you still want to consume stuff from Kafka, what's really cool about the whole Lambda thing is you can actually write your Lambda function in any language, and you don't need to worry about that. The poll is going to connect to Kafka and grab the data. You could write your, in binary or Rust or, JavaScript, TypeScript, PowerShell, like any language you like, and you could literally consume the data from Kafka. So that is also quite cool from a Lambda perspective, that you could have separate teams, maybe in completely different languages, being able to just grab data off your Kafka queues.
And moreover, you can configure that ESM to do additional very interesting things for you, right? We're going to share a link towards the end that talks about this in more detail, but what if you don't want to process those messages one by one, right? What if you want to process a bulk of 10 or 20 or 100 messages at once? What if you don't want to process every single message? What if only 30% of messages that you receive make sense for processing and the rest should be discarded, right? How do you actually do that without invoking your functions and spending, valuable milliseconds on that, right? So ESMs can handle all of that for you: batching, retries, filtering, many cool other things.
Okay, so the event source mapping is a managed polar that Lambda runs. In fact, in most scenarios, it's actually free. You don't pay for it, which is super cool. We do have a provision mode, which we're going to cover later, which allows you to pay for extra throughput, but also simplifies the networking. So it may actually make it cheaper to run than the other network. We will get on that. But Tejas, just let us know, like this polar. I mean, it's got I know it does a bunch of things. It's got polling, filtering, batching, and those kind of things. Can you just sort of explain internally the different functionality that the polar does before it sends the workload onto your actual Lambda function?
Yeah. So this has been a system, like this has been one of our key ingredients for making Lambda work so seamlessly with event sources. And what goes in there is massive investment on all fronts, which is feature development. I think we received a question on tumbling window. There is massive investment on the availability side of the world. There's massive investment on the reliability, and there's massive investment on the utilization, right? So we are giving performance guarantees to all of our consumers while making sure we are making it as feature rich as possible. I think if you try to replicate this functionality over on your own, it will take years for you to do that. And when you do that, as I said before, like right at the start, you're not focusing on your differentiated value that you bring to the market. Like what polars do today is there's a massive infrastructure and there's a huge team of engineers that continuously focuses on one thing: improving performance for you, giving you high availability, and making as many features as possible as available to the customers, which you can start using, as Anton called out, like batching, like a simple thing as batching. You can just turn it on with a click on the console, right? So there's continuous investments that goes on this front to make sure customers are able to focus on their application logic and not worry about any of the integration detail. You don't have to worry about security. You remember, like last year, there was like a Log4j vulnerability. If this had happened, like on some of the fleets, you could be sleeping in the middle of the night, and we would take care of it for you, right? So just an example, not that that was impacting us. So anything of that nature, right? Security, scaling, like we provide inbuilt scaling experience for you, and getting that right is so hard out of the box. We use multiple signals to make sure we scale as fast as possible. And I'm sure Anton, he'll probably share like an example with us that shows how it improves the customer experience, and not just scaling up, but we also scale down, right? Which is what makes us special.
Cool. Yeah. And I know actually Anton has got a demo brewing in the background, but because we want to show Kafka at scale, he's literally throwing vast amounts of messages at this Kafka cluster. So we're letting that ramp up. But yeah, just I know there are a lot of different ways that Lambda integrates also with different Kafka event sources. We've mentioned, the Amazon MSK, which is managed streaming for Kafka, Confluent, and ESM. Tarun, do you want to just talk about the different integrations and where you can run Kafka and that Lambda can actually connect to?
Yeah, absolutely. So Lambda supports the myriad, the spectrum of integrations. The way we structure it, or the form factors through which customers see it, is like you mentioned, ESMs. We have two categories of ESM. One is specific to Amazon MSK, and so you'll see that surfaced as MSK ESM. So any cluster that's built on MSK, you can use an MSK ESM to start using with Lambda. And the second connector layer we have is called self-managed Kafka ESM. Now, self-managed Kafka ESM is kind of a misnomer, because it's not just for self-managed Kafka, it's actually also applicable to our third-party integrations. So Julian, like you mentioned, the likes of Confluent, WarpStream, Redpanda, and so on, right? Like all those integrations that customers want to run, you can basically use the same setting within your self-managed Kafka ESM to be able to connect them to these third-party integrations. But generally, we support a delightful experience out of the box across these Kafka providers.
Okay, and that self-managed can be anywhere because it's literally connecting over the internet or via a private link. So it can be on premises, can be anywhere, and you're just connecting. Okay, exactly. And then the MSK integration is slightly different. That basically it's a networking construct that you need to either connect into the your MSK VPC, and that's why that's got a slight config difference. Okay. Exactly. Anton, I know you have. I know the demo's warming up, and we've got like lots of messages flowing into Kafka. So yeah, do we want to?
It's boiling, man. It's boiling.
It's boiling. I love it.
All right. Yeah. So, I mean, we're talking about like processing data, streaming data at scale here. Okay. So we can talk a lot about that, right? We're really good at talking, but I also wanted to show something live. So first of all, like fingers crossed, right? Demo gods, etc. Let's hope everything works. Now, I'm going to show you a demo that I used at reInvent a couple of months ago. So let me start sharing my screen. Okay, I'll start with one slide, well, a couple of slides that actually talk about what exactly I will be showing.
Cool.
Right? Okay, tell me once you can see my screen. Can you see it?
No, not quite. Hasn't come up that I can see. Oh, something's coming up. There we go. Yes, your screen is up.
All right, all right, all right. So, okay.
We've got your PowerPoint on. Is that what you were?
Awesome, awesome. So I'm going to be showing you an experiment, right? So I'm not going to be showing it like, the full experiment for the sake of time, but let me show you, visually what does on-demand scaling look like, okay? So what happens when you have a major spike in traffic, okay? So the blue line here represents records published to Kafka, and the orange line represents records consumed from Kafka through Lambda ESM. Okay. Now you can see that at the very beginning, right, orange and blue lines, they are aligned, right? My producers are publishing around 3,000 records per second, and my consumer is consuming at the same rate. But roughly around here, my published records basically increased x3, right? So now it's 9,000 records per second. And you can see that it takes ESM, the on-demand, the default ESM, several minutes to detect that and start scaling up. This is happening fully automatically for you. You don't need to create auto-scalers. You don't need to provision new instances of those pollers or consumers. This is fully automated for you, right? After some time, you can see that the consumption grew a little bit above published line, right? And that's because in those 7 minutes, some backlog was accumulated, and we need to process that backlog. But towards the end, you can actually see that those lines are aligned again, right? And my consumption and publishing, right, producing rate have once again in balance, right? So this is how on-demand works, right? Within several minutes, you will see that the ESM reacts to spikes or major changes in traffic, and it adjusts automatically. Now, let's show you something real, right? So
Anton, just to highlight that, because I mean, that's 7 minutes, but for a lot of workloads, that's absolutely fine, because there are a lot of workloads which are feeding data into a data lake when you don't necessarily need the real-time data, or populating a whole bunch of things. This is something you just don't have to do. The Kafka ESM is going to scale up. I mean, you've gone from nothing to hardly anything to 9,000 messages a second, and just like, oh yeah, this happened.
Absolutely, absolutely. So if you're as old as I am, you're probably familiar with JMeter, right? For some reason, I have a habit of using it. And I know that it's pretty tiny here, but if you can look at the throughput, you can see that currently I'm running at the throughput of about 5 requests per second. Now, what's happening in these 5 requests is I have a Lambda function, which I use as a message producer. And for every single request, I'm pushing 1,000 messages to Kafka topic, right? So 5 requests per second implies about 5,000 messages per second are being pushed into my Kafka topic. Now, if I switch back here, right, you can see my CloudWatch dashboard. This is live. This is going on live in real time. So the chart that you probably care the most about is right here. This is records flow. The blue line, once again, represents produced records per second. The orange line represents consumed records per second. And you can see that for the past 15 minutes, it fluctuates between something like 4,600 and 5,000, right? So it's roughly, getting close to 5,000. you can see that the chart here is pretty stable, right? Everything is pretty stable. There are no major spikes. You can see that here, that's the Kafka data point. The megabytes per second ingested is anywhere between 4.8 and 4.6. So it's pretty stable. Okay.
Yeah, so the graph looks as though it's quite sort of peaky and spiky, but that's just the top part of the graph.
Yeah, because you can see the upper and the top and lower bounds, right? It's not such a big difference, right? Oh, trust me, you're gonna see spike in a few minutes. So let's shake things up a little bit, right? So I'm gonna go to my JMeter configuration, and what do you say? Do we want to double the traffic? You want to triple it?
Why don't we let us know?
Let's make it interesting.
What are we doing?
Let's increase it by the factor of 5.
5x.
Right?
5x.
So
let's go.
Let me restart the test. Okay, I want to make sure that my throughput is significantly higher than it was before. So now we're going into 20 and above 20. Now it will take several minutes for metrics to update themselves, right? So let me stop sharing for now. We can maybe talk about a couple more topics, and then we'll go back to see the metrics.
Okay, yeah. So basically, you've now ramped it up from 5,000 messages a second to what, 20,000 messages a second. And in fact, the processing scaling is already doing its thing, but in the background, the metrics are eventually going on to the tablets. Okay.
One important thing to note here, right, is what I have in the background going on is what we call provision pollers, right? That's the new capability that we've introduced at reInvent a couple of months ago, right? You've made a really good point that about those 7 minutes, right? If I'm not doing, if I'm not handling super spiky traffic and I need predictable, close to real-time process time, if this is ingesting data in a data lake, 7 minutes is perfectly fine. Okay, probably my processing takes longer than that transport time. But what if I have those huge spikes going on all the time? What if my traffic is not a little bit spiky, but I've just increased it x5. I went from 5K a second to 25K a second. Okay, that's a huge spike, right? If I'm not properly scaling my consumption, I would expect to accumulate huge backlog pretty fast, right? But I am using provision poller that is prepared to handle this capacity, right? This traffic. So let's take a couple more questions, and I'll show you what the chart looks like, because I do expect real-time and predictable processing times here.
Okay, so we're obviously talking a lot about scalability. So, Kafka is built for high scale. In the way it does it from the Kafka perspective is, I know it's all about separate things across brokers and obviously partitions. So what should people think about from Lambda and partitions and everything? And Tejas, I'll go over to you. What's sort of going on under the hood, and how does, when Kafka can scale up as we're throwing loads of messages at it, behind the scenes, and how does Lambda figure that out and know, and how does it process things based on the partitions?
Yeah, so behind the scene, we have something called as event poller. That's our construct that's similar to a Kafka consumer that's running in the background. And to model how the system works, you can think about there's a Kafka queue. In the middle, you have the event polling systems, and then you have Lambda. What the event polling system is doing is it is orchestrating a wonderful, it's choreographing a wonderful dance here where it's trying to see how much can Lambda consume and what is the offset lag. We talk about the offset lag with Kafka queues. And at the same time, it is monitoring its own systems where we are monitoring CPU, memory usage. We are trying to figure out how much of the server is being utilized as we are processing these records. And we are trying to balance all of these things in a way that we either scale up when we start seeing we are falling behind. If the offset is going up, we start scaling our fleets up. If the Lambda function, which the customer, where the customer has written their business logic, that's falling behind. If we start seeing increased latency there, we start fanning out on our end. So all of this is happening continuously. Like every few seconds, we are evaluating how far behind the Kafka queue is. We are looking at the server metrics on our side, and we are also looking at how quickly the invokes are executing. Invokes is basically, we give the payload to customer's business logic, it executes it successfully, and the functions exits. So we are monitoring all three of them continuously and making sure, like, hey, if we see the customer is falling behind, then we start scaling our consumers up. The max number of consumers that you can get, by the way, is the number of partitions in Kafka, right? You can't go beyond that. But we make sure we scale up as quickly as possible so that we can fan out this logic across multiple consumers. Because let's say one consumer that's attached to a partition needs a lot more CPU because it's doing a lot of filtering, it's doing a lot of batching. Let's say it's a memory intensive process that we are executing on the polling fleet. Then we are going to scale out the consumers, right? So we'll make sure that scale up happens automatically. And provision poolers does it at a way faster rate. I think Anton's experiment will be able to show that to you very clearly, that it turns out to be very, very economical also at higher throughput. The more throughput that you send its way, it also becomes more economical to run provision poolers compared to our previous solution.
Okay, so just going back to that, so the takeaway to understand is we've got a super cool algorithm that sort of takes a whole bunch of things, but it's sort of three main factors to be able to automatically scale up your polars on demand. You mentioned about the three things I did. The number of partitions, the number of partitions in the topic, the backlog, so how the offset lag, and the offset lag isn't a time metric, isn't it? It's the number of actual messages in the queue.
It's the number of actual messages. You're completely right. It gets confused with iterator age with kinesis, if you remember. This specifically refers to how many records are in the queue, right? Okay. The difference between the records that you're processing versus how many are in the partition.
So we run this algorithm, and then we basically scale it up for you. You don't have to do anything. We're just gonna do that. But then you've also alluded to the this provision mode, which obviously seems to supercharge that. And just Tarun, if I can go over to you, obviously customers are always telling Lambda we want more, we want faster, we want bigger. But what are customers asking for that we needed a provision mode or something separate for Kafka?
Yeah, that's exactly. So I think like Tejas alluded to earlier, customers tell us they love this behavior around auto scaling that we offer, right? Like they already love the fact that Lambda, the ESM, can automatically detect your offset lag, number of partitions, and auto scale and auto up and down in a highly responsive manner. However, while that works for a lot of the workloads that customers are building, or let's say non-performance sensitive workloads, there are workloads which are much more performance sensitive or like throughput sensitive in terms of mission criticality, right? Like think of a real-time anomaly detection or an analytics kind of a use case where you need to give real-time performance to the customers, especially when you have spiky and unpredictable workloads. For such workloads, what customers told us is, hey, I love the fact that your ESM auto scales, but at the same time, why don't you give me the ability to control the throughput for an ESM, right? Which is the pipe connecting my Kafka cluster to my Lambda function. And so that's what customers told me. Now, essentially, when we ask them, hey, like, how do I give that control? And so that's when customers tell us that, fine, give me this ability to set a minimum number of these compute units called event pollers that Tejas was referring to, which poll from those messages, and the min and the max controls. For instance, if I have like 10 partitions and I have spiky traffic in all of the partitions, I want to be able to set my min pollers to 5 or 10 at max to be able to automatically start processing. 10 is the max, by the way, you can go, because to maintain ordered processing, an event poller can only poll from a single partition. At the same time, if customers want to limit the throughput to their downstream logic, they also want to be able to set, let's say, a max switch. And so basically, they love to kind of augment what we already offer with auto scaling. Customers wanted this additional control over the throughput for their latency or performance sensitive applications. And that's where customers told us, hey, give me this ability, this min max. And that's kind of the genesis of the provision mode that we ultimately launched in November.
Okay, cool. So yeah, turbocharging the polars, and again, we're still doing a whole bunch of stuff for you, but you just allow, specifically telling AWS, make sure we've got this minimum amount of polars, which are always going to be ready, and then a maximum amount if you want that as well. Now, I know there is also a cost implication to this. Tejas, do you want to take us through that?
Yeah, so there is obviously a cost implication associated with it. The event processing unit is the unit that we use to charge the customers. But here's an interesting thing. I know there is a notion of, oh, why should I pay an additional amount for this? There's obviously provision capacity for you. And as Anton called out, this is very useful for bursty workloads. But here's the other element with it. You never have to set NAT gateways for this. You never have to set AWS a private link for this. And that ends up saving cost as you start having higher throughput through your Kafka queues. So if you're having higher throughputs, this is going to be a cheaper option than the previous option, just because of the amount of messages that are flowing through the system, and you're no longer going to be charged for that because we have re-architected the system in a way that the customers no longer incur that cost. So as the throughput increases, this becomes a cheaper solution compared to the previous version, right? So from a cost perspective, as Anton called out, there's obviously an element of, if you expect bursty traffic, then yeah, definitely this is what you want to have ready to take the traffic that's coming forward. But if you also have high throughput and it's not bursty, this is the solution to go for.
Okay, yeah, no, interesting. I mean, in fact, that's actually awesome that there's something where you can have a turbo boost, and then at higher scale, everyone's like, oh yeah, serverless gets expensive at scale, but at higher scale, you're actually going to save more money because of the networking stuff we can do behind the scenes.
Yeah.
Cool. I love it. Anton, just let us know when you are on with the demo. I'm just going to go back, and we've got a whole bunch of people who've been sending some questions and comments. Just we've got an AWS TAM endeavor.
You know what? Let me quickly share it, right? So wouldn't people, okay. Because the more you run it, the better results you get, right? But I just want to quickly share it.
While you're sharing, I'll just bring up, we've got a T Bundu saying, good lesson from Facebook, love it. And I'm here to learn. That's what office hours. We appreciate that. We've got Lewis joining us from YouTube as well with a great hello. And then also C9 Zella says, is this the same system powering EventBridge pipes?
Yes. That's so we launched EventBridge pipes 2 years back. And the ESM system, which powers Lambda, is the same system that powers EventBridge pipes. And there was so much innovation that went into it. We ended up creating, like a generic platform that could be used to power EventBridge pipes. And it gets the same reliability, the same feature sets that we have on the ESM side of the world. So it's literally the same system that powers. And then, do you want to cover the provision polar story there? Yeah.
Yep. Can you see my screen?
No, not yet. Not yet. Hasn't popped up.
Okay, let me push the share button again. Screen and share.
Oh, right. We do have Amir Fidelia. Thanks for joining us on Facebook. Good evening, sir.
All right. Can you see it now?
Yes, it is up.
So just to remind you, right, with on-demand mode, it takes about, again, different tests can yield, some variety on the results, but it took about 7 minutes to start scaling, and then about 15 minutes to kind of process the backlog. If you look at the way, let me extend this a little bit, right? If you look at the way provision poolers work, right, focus on this point, right? So this is where I spiked my traffic. You can see that scaling starts immediately, right away, right? There is no delay for scaling to start, and it scales up quite fast, right? So this is happening within a span of 1 minute, okay? Now, how quickly, right, or how high it's gonna scale right away depends on how many provision poolers you have configured, right? So this is configurable, right? And you can say that, you know what, I want to have a minimum of, let's say, 3 provision poolers, right? And a maximum of 20. And in this scenario, right, you always have 3 of those running at any point in time, and they are there to accommodate the traffic spike. And once traffic spike exceeds those 3 poolers, right, the new poolers will be provisioned, right? And they will be provisioned faster than on demand. So not only you're getting those poolers faster, right, and you have the baseline capacity that is always there to process that, right? But it also happens fully dynamically. You don't need to change any configurations, right, to control that, and it happens right away. So you can see here that the traffic spike is handled properly, right? And just to show you on this screen, we started with about 4.6 megabytes ingested, and right now we're at over 20 megabytes ingested per second. So we're handling a huge traffic spike with zero effort, fully automatic.
So when you configure the provision mode, is that, it's obviously via API or infrastructure as code or console, and is that literally just going into the ESM and doing min and max, done?
Yep. You can actually just set min. You can actually just set them. You can actually just turn it on. Let's say you're in the console. You can literally select the tick box for provision mode and leave it there, because we'll automatically assign one event puller by default. And you don't even need to worry about it unless you have like very specific requirements around, you can actually then dial up and then tailor it to your requirements. But otherwise, there's minimal action required on the customer's behalf.
So there's a minimum polar of always one. So even just turning it on will always have a polar there. And yeah, I suppose it's a single polar's, the relation. A single polar can consume data from multiple partitions, can't they? Or am I messing that up? Because I know it's going to have one partition. If you have multiple partitions, a single polar can grab from multiple partitions, but send it to a single Lambda function.
That's correct.
Yes, but yes, exactly. But at the same time, it does not help to have your event polars more than the number of partitions.
Yeah.
So that's the nuance I think we want customers to be aware about.
That's actually a very important point, right? Because with Kafka, you do support ordered processing, right? And records are ordered within those partitions, right? So unlike SQS, right, where we can create you have one queue and we can create thousands of execution environments to process those messages, right? With Kafka, the number of execution environments, Lambda execution environments will create will be capped, right, by the number of partitions that you have. Right, because if you have 10 partitions, we cannot have 12 execution environments, because this way we will not be preserving order. And with Kafka, it's pretty critical to preserve order, right? So this is one of the ways you can scale your throughput, right? Increase your throughput, right? You can increase the number of partitions in Kafka. That will allow us to create more execution environments to process data. So that's one of the common techniques of increasing throughput.
Yeah, and actually C9 Zealous had a comment, and yeah, we appreciate you joining us via Twitch. When can we? So it was talking about the innovative features of partial batch response or tumbling window streaming analytics. So we spoke about tumbling window streaming analytics. Your request is heard well by the product and engineering teams here today. But I actually just wanted to quickly pick up on the partial batch response. That in a way, and keep me honest here, Anton, for partial batch response, that's more for something like Kinesis, where you actually go back to Kinesis and then delete the messages off of the queue which have been processed. With Kafka or with Kinesis or with real streaming protocols, you don't actually ever delete anything off the queue. If something isn't processed, you will grab the same batch and reprocess it, which we'll get onto error handling shortly. But yes, I don't think partial batch response is actually something that you would ever need with Kafka?
So with Kafka, right, it's a streaming event source, right? So like SQS, like we mentioned, Julian, for example, SQS, a single consumer reads a message, processes that message, deletes the message from the queue. If consumer is processing 10 messages, they can say, you know what, successful processing 5, the remaining 5 should not be deleted from the queue. They should remain, and maybe some other consumer will process them. Kafka is different. You do not delete records from the topic. The topic has a configuration for expiration, right? You can say that the record should expire after 24 hours, and multiple consumers can read the same records from the topic, right? So none of the consumers ever go back and delete those records, right? You can actually start reading from literally any point in time, the latest, oldest, or anywhere in between, right? One more thing to add to partial response failures is once again, right, ordered processing. If you receive 3 messages to process, you cannot say that only the one in the middle was successfully processed, right? This kind of this can break the order. So partial batch processing with ordered processing can get pretty tricky.
Yeah, so no, that's good info. And then also, it also means that if you have some failure processing a single message and it is going to continually fail, those messages it's not going to progress, and you can actually back up your stream, which can cause you severe issues. So if strict ordering isn't strictly required, within your code, you need to handle that failure and send that message somewhere else for reprocessing, so your stream can carry on processing. Because the worst thing you want is a backlog where your stream carries on building up a backlog you're not processing, and then on the back end things are falling out of the stream and you don't realize. So yeah, I know we've got some other topics we wanted to cover, something like security. So how does Lambda then handle the authentication and authorization? Because obviously Kafka's got lots of different options for that. Whoever wants to pick that up.
Okay, so we support all of the standard options across our event sources. Obviously, there are minor differences depending on the type of event source. For example, for self-managed Kafka, we do support SASL, Scram, and TLS. That's like a popular authentication mechanism that's used. We support SASL plain. Obviously, with encryption, we have IAM-based authentication that's available with MSK and MSK Serverless. Those are two options that are available there. So all the industry standards protocols are supported on our platform. We don't deviate from those. And as I said, like you would store your credential if you're using SASL, you'll store it in AWS Secret Manager, right? And if you're using AWS MSK, your secret name must start with the prefix of Amazon MSK. And their Amazon MSK serverless, it only supports IAM, right? So they all abide by the same AWS standards that we have. Obviously, there are some differences depending on the compatibility of what version you're using. If you're using self-managed Kafka, then obviously IAM won't work in that situation for the right reasons, because you're managing all of the authentication. But in that case, as I said, you can use SASL, Scram with TLS.
Okay. Excellent. Thank you for the security. And then, yeah, I was just talking about some of the, poison pill messages and some of the error handling and dead letter queues. So we talked about it, message getting blocked up. But yeah, Anton, do you want to just cover, what are best practices people should be thinking about for error handling, dead letter queues? Some more information on that. I'm thinking, destinations. Yeah. What else should people think about?
Yeah. So Lambda allows you several ways to handle errors, right? And it's important thing to account for errors, right? You can please never assume that your code is flawless or my code is flawless, right? There are going to be errors, right? If it can fail, it will fail, right? Trust me, right? Now, Julian, like you've mentioned, right? The system, right? ESMs and Lambda, they will help you with retries, right? They will help you with some things to overcome those errors, because guess what? In many cases, a simple retry is a solution to your problem, right? But in some cases, it is not, right? And if you do have, ordered processing failing to process a particular message or record can actually block the whole backlog, right? You should account for that. So what do you do in these scenarios, right? Well, gracefully handle that in your code, right? Whenever you're processing those records, right? Something as basic as try catch, right? Try to catch those exceptions and handle them. How can you handle them? You can have a DLQ, right? A simple example, right? You know that this message is failing to process, right? So you put it in a different spot. You delete it from your Kafka, from the original event source, right? And you put it in a special place for messages that fail to be processed, okay? We call that DLQ, dead letter queues. Okay, that's one example, right? For asynchronous invocations, for example, if you use Lambda with asynchronous invocations, we have a notion of on success and on failure destinations, right? So you don't have anywhere, like it's not a client invoking your function and you can return HTTP for 500 or 400 to them. It's it's a different kind of invocation, but you still should be able to put the successful processing result or failed processing result somewhere. So we call them on success and on failure destinations, and those can be different things, like for example, a DLQ, right? I mentioned DLQ, right? Another Lambda or Kinesis. What else we support there, right?
Event Bridge, SNS.
Event Bridge, SNS. Yeah, there are quite a lot of those, right? So you can put the payloads that were successfully processed, the results of the processing, right, in success destination, and also the messages you failed to process on failure destinations.
Yeah,
Cool.
and this is such a best
yeah.
practice, by the way. I think what Anton is mentioning, I've seen customers, not configuring the DLQ settings or using S3 as a destination, especially in cases where you fail to process those messages. It's such a best practice to make sure, you can go back to those messages and retry them or have any further investigation on what went wrong. We talked about the poison pill records just some time back. So this is such a best practice. Just want to make sure, when you set these up, this is another thing that's available to you with an API call. You can just set this up and it starts working for you, right? But such a good practice.
Cool. Excellent. Thanks, Tejas. Yeah. Obviously, our observability is big. Vinay, thanks for joining us via YouTube. Vinay is asking, what are the KPIs we need to check in case of event polar performance apart from the provision polars? So, yeah. You obviously had some cool graphs up, Anton. What can you tell us about observability?
Yeah. I love this question because I have a really good slide for it.
Perfect.
Right. Yeah. Like I mentioned, towards the end of the session, we'll share a couple of links that kind of summarize everything we've talked about and provide you more information. But specifically for that, let me actually share my screen once again. Okay. Present, share screen. Okay.
Coming up soon.
Can you see my screen?
Not yet. I think Kinesis. There we go. Yeah, we're up.
Can you see? Oh, all right. So these are slides that I use to reinvent, right? And essentially the idea here is we have tons of various metrics for event sources and we have tons of various metrics for functions. But what about this awesome magical box in between that's called event source mapping? Okay, so that's actually something we addressed at reInvent, right? You have a new checkbox in your Lambda console, or obviously you can also enable it through infrastructure as code or APIs, which allow you to enable metrics for enhanced ESM observability. Okay, so to give you an example of what it looked like, right? So imagine you have in this scenario, I'm using a screenshot from Kinesis, right? Now, when I enable those metrics, I'm starting to get this information out of the box with CloudWatch metrics, right? So out of the box, I'm getting polled event count and invoked event count. So I can actually see that the number of events that were retrieved from Kinesis and the number of events that essentially reached Lambda, that Lambda was invoked with, are roughly the same, right? So this gives me assurance that data processing, the workflow works, right, basically. And you can see at the very bottom there, failed invoke event count. So it's at 0, which means, okay, looks like I don't have any failures, I don't have any problems. But imagine you add some advanced functionality there, right? For example, you add event filtering to your ESM. So this is what your dashboard gonna look like. Now you have the polled event count, right? But the invoked event count is a little bit lower. That line is a little bit lower. By how much it is lower? Well, roughly by that yellow line. It's filtered out event count, right? The number of events that ESM retrieved from Kinesis or other event sources for you, but it filtered them out. According to your configuration, you've declared, I don't care about these events, just discard them, right? And this kind of gives you a really good visibility into how data is flowing through the ESM system, right? How many events are polled, how many events are failing, being processed, being filtered out, etc. So you can see that we've introduced 7 of those metrics for different services, right? You can see the matrix here. Some events only make sense for some services, like deleted event count only makes sense for SQS, right? You don't delete from DynamoDB streams or Kinesis, right? But most of them would actually apply to all the services. So using these metrics, you just need to enable them, right? Using these metrics, you can actually monitor the internal performance of ESMs, how many events are flowing through your system. And when you see some numbers that raise a brow there, you can actually start debugging, trying to understand what's going on. For example, maybe you forgot to introduce failure handling, and some events are basically failing to be processed.
Okay, and just on that last slide, you did say Kinesis, but those metrics are also available for Kafka, just in case people are thinking that is...
They are not available with Kafka right now. But
Okay,
I think what Anton mentioned is still relevant. right? And maybe we can talk about whether those metrics should be available for Kafka too soon enough. Like we are working on that. But again, to answer the same question, just to add on to what Anton already said, is that you want to look at a few more metrics. You can look at your offset lag. How's that looking like? You can look at your Lambda function duration. That tells you if the function duration is increasing, you're going to see a little bit of bump in your offset lag. And you want to look at your Lambda errors and invocation. This is again already available in CloudWatch as part of your function metrics. And you should look at the MSK topic bytes in per second, like how many bytes are getting into your MSK topic. If you look at these 4 metrics, offset, Lambda duration, your invocation and errors in a single metric, and the last one being MSK topic, how many bytes per second are going through your Kafka queue, you should be able to get a sense of what's going on, like how the polars are keeping up or how your function is keeping up. In most cases, by the way, the event polars or the provision polars, we have our own custom metrics that we monitor internally, by the way, to make sure we are not falling behind even for a single customer, right? So if we see the latency increasing or the throughput reducing for any customer, we have alarms that fire and we act on it immediately, right? So customers don't need to worry about it. But the metrics that I'm referring to are the ones that customer control for themselves, right? If they have introduced a piece of code in their Lambda function, that's going to take, let's say, twice the amount of time to execute a payload. Yeah, you're going to see an increase in the offset lag. We can try fanning that out on our end on the event polar side. But remember, everything in partition goes out sequentially. If the partition is backlogged, our fanning out won't help. There's an interesting feature which is available today, by the way, on Kinesis, which is virtual shards, which might be available on Kafka too at some point. But again, these are the core metrics that you can use today, by the way.
Just wanted to add to Tejas. So for customers using provision polars, we also have another metric, like for customers interested in knowing how much of my polars are actually getting used. There's also a metric called provision polars used. It's a CloudWatch metric. It's called provision polars used, right? Like where customers want to understand with traffic, how many polars is my ESM really spinning up, because that ties back into what they're charged for in terms of event polar units or EPU hours. So yeah, just to +1 to everything Anton and they just said, and another metric for those interested.
Cool, excellent.
And quickly add on top of that, right? If you use Lambda Power Tools, which has a really nice integration with CloudWatch metrics, you can emit additional custom metrics, right? So we provide you with out-of-the-box metrics for how the service operates, right? But you, in your function code, you might have some additional business level metrics, right? For example, you want to measure some end-to-end latency that includes systems we're not aware of. So you can use Lambda Power Tools to emit those custom metrics to CloudWatch metrics, and you can see them on exactly the same dashboard. So this is a really powerful capability.
Cool, thanks. Yeah, and just quickly, we've got a minute left, but Shubham asked, is there a plan to emit end-to-end processing time as part of the enhanced ESM observability? Is there an end-to-end one, or do people currently need to construct it from other metrics?
Yeah, so currently we don't emit an end-to-end metric, but what the problem with event pooling systems is the request is hopping across multiple systems. The best way to get that view is using something like X-ray, by the way, right? That would allow you to stitch this across multiple systems. But currently there is no end-to-end event processing latency. It would be great if you could get that out some way. But X-ray currently allows you to do that.
Okay, excellent. Well, thank you, everybody. What a pleasure to be able to get such a deep dive on all things Kafka and Lambda. Really appreciate the time, Taram, Tejas, and Anton. Yeah, great demo. Hopefully the smoke isn't blowing up in some data center somewhere with all the data records you are pushing to Kafka, but I know Lambda was handling it seamlessly. So really appreciate all the time today. Serverless Office Hours will be back same time, same place next week. Working on a few kind of things. We're thinking we may be doing some exciting things with step functions, but we'll let you know shortly. But yeah, the info will be out. Oh, there is a YouTube video. I gather that on the actual stream links on all the different platforms, there will be a message showing this link as well. But yeah, this is plenty more information all about with lots of links within this. This is Anton's talk at reInvent, which was absolutely fabulous. So yeah, certainly worth having a look all about that. But yeah, everybody, thanks so much for the link in the chat. Yeah, you are asking. The link should hopefully be appearing in the chat shortly. I can't quite do that myself, but our excellent producers will sort that out. But yeah, thank you everybody for joining us today. See you same time, same place next week. And yeah, really appreciate the three of you joining as experts today. Goodbye. Bye-bye.
Thanks for having us.
Have a good one.